Hello everyone, welcome to my new video. Today I'm going to talk about I'm going to show how we can rewrite some of the design patterns using new Java language features. So before I go into the implementation that I would say yeah, we can use language design patterns in our in our development, but it is not a thing that you have to use all the time. So if you can write a good readable and also a code that we can easily introduce new changes, I think that is really good enough. So you don't have to always stick to the design patterns. And I also don't really worry about design patterns because I even in interviews I don't really I don't ask too much about the design patterns from the candidate as well, because what most important thing is how we can get the work done. And some language they provide better alternatives to for these design patterns. So now Java introduce some of the features, and with those features we can rewrite some of the design patterns, or maybe yeah, we can re-implement some of the design patterns using those new language feature. So we are going to focus on to this video we are going to focus on three design patterns: singleton, strategy, and the visitor. So first I'll start with the strategy. So for this one we are going to create a small simple calculate application. So basically we can pass two numbers, and it can give a number as output depending on the strategy or the depending on the operation that we pass to that calculator. So calculator can perform one operation at a time. So let's see the class. So this is the class. So we have a calculator and we have a math strategy. So we have set a method to set the strategy, and we have a method called calculate. So it will take two double values and do the operation and return the output. So if you go to the math strategy, so it has a simple method called do operation, takes two numbers and returns double value. So if we check the implementation of this, so we have add operation. So basically we take two inputs and we add those two values and return the result. And we have multiply, and we have subtract. Same way we can implement the division as well. So let's see how we can use this calculator. Okay, so I'm going to create a calculator. Then I'm going to create a for this example I'm going to use add operation. So I'm going to create an instance from the add operator one new add. Then I'm going to set it to the calculator cal.set strategy add. Then I'm going to uh, add two values. So in this case I'm going to use 10 and 6. So calculator calculate 10 and 6 6. So I'm going to execute program. Here you can see the output is 16. So this is how we normally implement strategy pattern in Java. So but with new language features, especially with the features introduced in Java 8, we can rewrite this strategy pattern. Let's see how we can do that. So first of all, we are going to remove the math uh, strategy interface. I'm going to use a function function interface introduced in Java 1.8 called by function. So it's basically a function that takes two values and return another value. So we have to mention the two inputs. So in this case, double and returns a double. Then we have to change the set strategy method, take by function, double, double, and we have to change the do operation method to apply. This is how our calculator class looks like. Then we're going to the application and we have to change this, so we don't need this and this. So I'm going to create, so for now what I'm going to do is I'm going to implement the add operation using Java lambda function. So by function double double add and equal, going to get two numbers as inputs and it's going to return num1 plus num2. Then what I'm going to do is I'm going to add this function to calculator, set strategy, add. I'm going to calculate the I'm going to add 10 and 16 like just like previously. So let's see the output. So we get the same output. So this is how we can implement the strategy pattern using Java function. So basically what we say that we can replace the strategy pattern using high order functions. So the benefit of this is that we don't have to create separate classes for each operation. We can use lambda functions for that. For example, if we want to create a function for subtraction, what we can do is we can create a by function double 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 sub. Just take num1 num2 then num1 minus num2. Just like that we can uh, add another operation without creating class. So there's another benefit of this method, this approach, that we can easily extend the capabilities of the add function. For example, if you want to create a complex operation, like we want to add two values and then we want to calculate the square root of that added value of that value, so we can easily do uh, with the strategy pattern. If you follow the previous the if you follow the strategy pattern, we have to create a separate class for this one, but for if you are going to use a functional pattern, we can just create another, we can easily extend that capability without creating another class. So let's see how we can do that. So I'm going to create a complex operation. So I'm going to use the add and then there's a method called and then there I can specify the value. So I'm going to use d and math dot square root d, and then what I can do is I can use that complex one, pass the complex function to the calculator, and then we can run the application, see the out. We are getting the expected out. So this is another added benefit of using functional approach to implement the strategy pattern. We can easily extend the capabilities. So we can improve this a little bit further. So instead of directly using a by function, we can use by operator. So let me change that. So binary operator. So this is basically extended version of by function. Then what we can do is we can change this to binary operator, and then pass the operation and operation to here. So this is how we can improve this function approach a little bit further. So you can use either by function or binary operator. In this case, I think binary operator is more suitable and more readable than by function. So this is how we can rewrite strategy pattern using higher order functions of functions. Now let's see how we can rewrite visitor pattern using new Java language features. So for this one, I'm going to use Java 22. So we are going to use seed classes or the seal interface and records, and also the pattern matching. So this is, so in here what we are trying to do is we have few different shapes, and we are going to convert those shapes into XML. So we don't want to add that that XML conversion logic into each shape. So we are going to use a separate class, and that class is going to convert those shapes into XML. So this is how we implemented. So we have circle, we have rectangle, we have triangle, and also we have the visitor interface, and also we have the simplest version of XML visitor. So the visitor XML visitor, we have implemented all the methods related to each interface. Let's see how we can rewrite using Java features. First of all, we are going to create an interface called shape. So this is going to be a public seed interface shape. All right. So then now what I'm going to do is I'm going to permit circle, rectangle, and triangle. Then what I'm going to do is I'm going to each class, and I'm going to convert this each class into records. Record int space int height int x int y. Then what I'm going to do is I'm going to remove all of these things. That's it. So now what I'm going to do, I'm going to shapes. I'm going to try a rectangle. I'm going to connect it to a record. Then int x, int y. Then I'm going to get all. Yeah, I'm going to delete to here. Then from here to here. Right. Then I'm going to circle. So I'm going to convert it to a record. Then int radius, int x, int y. Then I'm going to implement shape. Save it. Then triangle. Going to implement shape. Save it. Then rectangle. Going to implement shape. Then what we are going to do is we are going to visitor interface. So we are going to visit interface and we're going to remove all these methods. We are going to introduce new method called void visit, and this method is going to get uh, shape. They are going to go for the implementation XML visitor. So what we can do here is we have to implement public void visit shape. Okay, now here we are going to use the pattern matching. So we are going to switch statement, switch, return with the default. So switch. Then what I'm going to do is I'm going to go through each and every type. So we have see a circle, and we have case, rectangle, and we have case, triangle. So we are going to do deconstructed pattern matching for the circle. We have to get the int radius int x int y, and for the rectangle it's int x int y, and for the triangle int x, so int base int height int x and int y. Right, now let's see. So this is how we can use deconstruct pattern matching, so we don't have to separate method for each type. We can expect the interface, since we have permitted to implement this interface only for these three types. We can easily we can use switch statement to go through each types and check whether the shape is one of those types, and we can do the necessary implementation. So let's see. um, right, let's convert circle into XML. So I'm going to copy same thing I have here. That is easy. I'm going to paste it here. We don't need to call circle.get like that. We can say x, y, and radius. And we can do the same thing for rectangle as well. Here, I paste. So here also we don't have to say rectangle dot get x, just x, y, and for the triangle we can copy the same thing, and here paste. How to say the base dot shape dot get base, just base. Then can use height, just x, and I'm going going to delete everything from here to here. So let's see our output. So I'm going to so let's use this new implementation and convert few shapes to XML. So I'm going to create XML visitor and visitor. I'm going to create a circle. Radius 10 x I. This is let's convert this to XML. XML visitor visit circle. Let's run the application. Here we are getting the expected output. So this is how we can rewrite the visitor pattern using Java new language features, especially seal interface, records, and deconstructed pattern matching. So with this we can easily write a more readable code. Yeah, that's how we use how we can rewrite a visitor pattern using Java new features. Okay, now let's see how we can implement singleton pattern using Java feature. So this is not a new language feature, so we are going to use enum for that. So I already created enum called configuration. Let's go to that. So this is how you implement a singleton pattern. So in here, I want to create a one instance of this configuration, and I want to share that with the entire application. So the benefit of using singleton is enum is that it is simpler because it's easy to understand. We don't have to create a separate instance, static variable. We don't have to create a method to get that instance. We don't have to worry about synchronization, all those things. It is very easy to implement and simple. And also it is thread safe because enums are inherently thread safe in Java, so we don't have to worry about synchronizing the methods. And also it always guarantees single instance because enums are guaranteed by this Java language specification to have a single instance. So that is the main benefit of implementing singleton pattern using Java enum. So all you have to do is you have to create a variable. You can use whatever the name you like. For in this case, I use instance, and I create a private feeds to maintain the instance variable, and this is a constructor. So you don't have to put anything like public or private because enum constructor are private by default. And in this case, I'm basically reading configuration from a configuration file and assigning it to a properties variable. And I introduce another method to get some properties from the values of the properties using key. So this is how our implementation looks like. Then let's see how we can use it. Let's go to app, and what I'm going to is I'm going to assign this to a config, then config configuration dot instance, then I'm going to whole config dot get, then I can pass. Yeah, this is how you use that instance, uh, enum instance, and invoke the methods in that. So this is how we implement singleton pattern using Java 8. So this is not new. This is existed even before Java 8. So if you can use enums, then use it, because you don't have to do, you don't have to worry about thread safety or anything like that, because all those things are handled by the Java itself or the JVM itself. Yeah, that's all about the today's video. So let's meet you guys in another video. Bye.